Continue natin mga Lodi. Dito na tayo sa number 5. Now, this is a worded problem, no? Walang figure na binigay. So, we have to form this. So, we have daw a 12-meter simple beam. Sabihin natin, hinge dito. And then here, we have a roller. And then, meron daw 3 concentrated loads at the middle quarters. So, ibig sabihin ng middle quarters is meron tayong 3 loads, which is like this. Change ko yung thickness. This is P equals 90 kN daw. Meron dito. And then, also here. Now, EI is constant, and then calculate daw the slope at 2 meters from the left support. So, we want the slope at this point, somewhere here. Kasi diba, the span is 12 meters. 12 meters, divide natin by 4. 12 divided by 4 is 3. So, this is 3 meters, 3 meters, and so on. Yan. And so first, we need to solve the reaction. Now, in your structural theory, meron na tayong general formula para dito. If you have 3 concentrated loads at middle quarters, diba, yung reaction is 1.5 P. Or simply, 1.5 times 90. So, AY equals 1.5 times 90. This gives us 8 times 90. We have 135. So, 135. And then, dito rin, 135 kN. Yan. So, applying double integration, you can actually use any method. Depende na yan sa diskarte mo. So, I will just use double integration. So, first, I have EI y prime prime. This will describe my moment equation. So, here, I have, again, the origin is from the left. So, lagay natin x. And then, I have 135 multiplied by x going to the cut. Again, our cut is just right before the last segment. So, move na lang natin. So, this is EIY prime prime equals 135 multiplied by x. And then, minus this load. This is 90. This will cause a counterclockwise rotation about the cut dito. And then, its moment arm about the cut is this distance. Yan. Which is, diba, x minus 3. The whole distance minus this one. And then for the other one, this is x minus 3 plus 3. That gives us 6. And then for this final load, this is x minus 9. So, 90 times, again, we have to use pointed brackets para maiwasan natin maging negative yung nasa loob. So, 90 times x minus 3 and then minus 90 times x minus 6 and then minus another 90 but multiplied by x minus 9. So this is now our moment equation. Now you don't have to simplify this kasi sa double integration, we want the singular moment equation. Huwag mo na itong i-simplify. This is what you will integrate. And so next, we have EI y prime. This now defines our slope equation. So we have here moment and then slope. And then for the slope equation, we just have to integrate this expression. So we have 135 multiplied by x squared divided by 2. Again, plus 1 sa exponent. Tapos divide mo sa kung ano yung result. And then minus 90 times x minus 3. This will become squared and then divided by 2. And then minus another 90 times x minus 6 squared divided by 2. And then minus 90 times x minus 9 squared divided by 2. Now, we still don't have boundary conditions. So ibig sabihin, we need to add an arbitrary constant. Kasi diba, when we integrate, meron kasing lalabas na constant of integration. So we have plus C1. Yan. And then we can solve this later by applying the boundary conditions which occurs due to the supports. And so now we're gonna form the deflection equation. So for the deflection equation, we have EIY, and then this becomes 135x cubed plus 1 sa exponent, and then divided by 2 times the new exponent, so 2 times 3, and then minus 90 times x minus 3. This will now be cubed divided by 2 times 3 again. Now you can simplify this right away. This will become 45 times x minus 3 squared. But my approach is, I will just simplify when I am already on the last step para maiwasan yung errors. So we have minus again 90 and then x minus 6. This becomes cubed and then divided by 2 times 3 and then minus 90 times x minus 9 cubed divided by 2 times 3. And then once we integrate C1, diba, this already has x. So C1 times x. And then since we integrated 2 times, merong another arbitrary constant. So plus another arbitrary constant which we'll label as C2. Yan. Now sir, how can we solve C1 and C2? To to solve C1 and C2, you have to apply the boundary conditions. Now, it occurs at the support, so let's check the distances. Bale, at this point, we have a hinge. So, dito yung support. Now, this is at x equals 0. Now, diba, if we have a support, deflection is not permitted. So, meaning, at this point, at x equals 0, the deflection must be also 0. And then, dito naman sa ruler support, this is at x equals 12. Diba, deflection is not also not permitted. So, y equals 0 then. Now, tandaan mo lang na if you have a boundary condition at which x equals 0, y equals 0, automatic C2 becomes 0. Kasi kung papalitan mo lahat ng x dito, automatic 0 na yan. So, remove na lang natin. This is 0. And then for C1x, to solve C1, you have to apply the other boundary condition. At x equals 12, y equals 0. Yan. So, yung gagawin natin is, we have to set y to 0. Copy natin. Applying this boundary condition, papalitan natin to ng 0. And then lahat ng x values, lalagyan mo ng 12. Yan. Now, notice na 90 is common. And so, you can actually factor this out para magkakasya sa calculator yung buong expression. Diba? We can rewrite this as 0. This becomes 0. And then 135 times 12. This becomes 6. And then minus, lalagay ko na lang yung 90 over 6. Kasi diba, it's common for all terms. Minus 90 over 6. And so, lalagay ko na lang dito yung 12 minus 3 cubed, and then plus 12 minus 6 cubed, and then plus x minus 9 cubed. And then I have plus C1 multiplied by x, which is also 12. Now, sir, ba't to naging plus? Diba minus? Yung minus kasi, nilagay ko kasi dito. So, that's why this now becomes plus. We factored it out. So, setting this expression to 0, and then, by the way, this is also 12. We can now solve C1. So, input ko lang, 135 times 12 over 6 minus 90 over 6, and then 12 minus 3 cubed plus 12 minus 6 cubed, and then plus 12 minus 9 cubed, plus C1 multiplied by 12 equals 0. So, solving C1, saglit lang, plus 12x. Solving C1, I have 1192.5. Yan. And then now, I'm gonna solve the slope at 2 meters from the left support. So, this is at x equals 2. So, diba, slope yung kailangan natin. So, we have to use the slope equation. So, copy natin. And then, as what we have solved, C1 is 1192.5. So, plus 1192.5. And then we have at x equals 2. Yan. Now, lahat ng terms dito, basta pointed brackets yung gamit mo, it cannot be negative. So, diba, if I will substitute 2 dito, 2 minus 3 becomes negative 1. So, that means that I have to exclude this expression. Saka, ito rin. Kasi 2 minus 6 becomes negative. Again, what's inside cannot be negative. And then I can also exclude this one. And so what's left is 135x squared divided by 2 plus 1192.5. And then we have EI y prime. And so solving y prime, that's the slope. Then I have 135 times 2 squared divided by 2 plus 1192.5. So this gives me 135 times 2 squared over 2 plus 1192.5. This gives me 1462.5. Now, medyo may mali. Check ko lang. The answer has to be 1755. Virtual work kasi yung ginamit ko. Wait lang. 135 x minus 3, x minus 6, x minus 9. Wait lang Papakita ko na lang. Display capture. Lagay ko na lang dito. Yan. So, just download this app. Tawag dito, deflection light. So again, our span was 12 meters. And then we have 90. Medyo naglalag. 90 kN at 3 meters. 90 at 6. And 90 at 9 meters. Yan. So, set natin to 100. And then for the slope, set natin to 10,000. So at 2 meters, 2. It has to be minus 1755. Now, dito tayo nagkamali. Yung C1 dapat minus 2025. Now, I will try to double check. Calcu. Okay. Ito pala. Hindi natin na cube. Meron kasi itong cube. Sorry. So, this must be cube. So, again, 135 times 12 cubed over 6 minus 90 over 6. And then, 12 minus 3 is, let's just change this into 4. 9. This is 6. And this is 3. So, 9 cubed plus 6 cubed plus 3 cubed. And then, plus C1 times 12 equals 0. So, resolving C1, we have minus 2025. Yan. So, this is also minus 2025. And then, change natin. Minus 2025. This now gives us 135 times 2 squared over 2 minus 2025. We have minus 1755. And then this is kn m squared divided by ei when we want to solve y prime. Yan. Now we have number 6. So this is now a frame. So we have to apply virtual work. We have this problem and then figure is TOS 004, which is this one. Yan. Problem 6. Inclined, so virtual work. Okay. So, diba, yung first natin gagawin is, this is actually determinate, but we have to form a virtual system and we have to also form the real system. Now, this is my real system. Yan. And then, let's try to solve the reactions. So, for the reactions, we have a resultant right here, which is 10, the load multiplied by the distance. So, 10 times 5 gives us 50 kN. And so, I can take moments about C to solve for AY. So, we have AY. We also have AX. So, setting this to 0, we have AY times 1.5 plus 1.5 plus 5 meters. And then minus 75 multiplied by 1.5 plus 5. And then minus 50 times 2.5. So, this is equal to 0. 75 times plus 10 times 5 times 2.5 plus, okay. So, x times 8 minus 75 times 6.5 minus 50 times 2.5 equals 0. We have 76.5625 for EY. 25 kN. And then, for CY, we can just sum up forces vertical. So, we have minus 75 minus 50 plus 76.5625 plus CY. Set natin to 0. CY is 75 plus 50 minus 76.5625. We have 48.4375. And this is Kn. Yan. Now, for virtual work, you can only apply moments by segment. So, if there is a change in loading, then you have to add another point. Now, diba, at this point, at the application of 75 Kn, there is a concentrated load. So, we can label this as, let's say, point D. Yan. A, B, B1. So, I actually have 3 segments. This is the first segment, second segment, and then this is the third segment. But I must first solve the reactions of the virtual system. So, copy natin. Diba, for the virtual system, we have to calculate the vertical displacement at joint B. So, vertical displacement, ibig sabihin, we have to apply a unit load at point B, which will cause a vertical displacement. So, dito sa point B, I have to add a unit load. Lagay natin 1. And then dito sa virtual system natin, this is the virtual system, we have to exclude all the loads. So, itong 75, wag mo na yung i-consider. Saka, itong 10 kN per m na load. Sa virtual system, only the unit load must act. So now, solving CY, saka AY, we have summation of moments about C. This is AY multiplied by 8. And then, minus 1, this unit load, multiplied by 5, equals 0. So, AY is 5 divided by 8, which is in decimal, 0.625. So this is also 0.625. And then solving CY, we can sum up forces vertical. So we have CY equal to 1 minus 0.625, which gives us 0.375. Yan. Now, we can make a table to simplify our solution. So we have here, first, you're gonna write a column for the members, and then next, you will input the limits, and then you have the moment equation of the real system, and then you're gonna follow it up with the moment equation of the virtual system. So we have here MV. And so for the members, we have three segments. We have AD, DB, and BC. So AD, DB, and BC. Now we want to take moments dito sa AD, DB, and BC. But then we first have to establish the limits. So what will be the limits? Now, diba, this height is 4 meters, yung height na yan, and this base is 3 meters for this triangle, yung triangle na yan. Now, your limits have to define the length of the member. And so, if this is 3, and this is 4, then the length of this member must be 5. So, this is 5 meters. But then, since this is divided into 2, because we have 1.5 and 1.5, then the length of member AD must be 2.5 meters, as well as member DB. Yan. So, for the limits, I have 0 to 2.5, but lag. And then for DB, I have also 0 to 2.5, while for BC, I have 0 to 5. Again, it's helpful to write, to establish your first limit as 0 so that it will be easy to integrate. And then for the moments, we have to take moments about each segment. So this is gonna be my first cut for segment AD, and this is my second cut for segment DB. And then for segment BC, it's helpful to form the moment equation from the right side. So this is going to be my cut. And then I will consider the right side for this one, and then I will consider the left side for this part. And then for segment AD, I'm also gonna consider the left side. So now, I'm gonna form the moment equation of the real system. Now, by the way, AX is just 0 because we don't have any horizontal loads. So, forming the moment, we have 76.5625, the reaction at A, and then I have to multiply this by the moment arm going to the cut. Now, if you zoom in, diba, the moment is a perpendicular distance. So, we're not gonna use X parallel to the length of the member. The value of X must be from this point patungo sa cut, yung cut na yan. Now, what is this horizontal distance? Diba, we have to define this in terms of the slope. So, this is, let's say, X. And then, we have here, ito na lang, masyadong lag. Wait na. Close na. So, this is a 3-4-5 triangle. 3-4-5, and then, diba, we can describe the horizontal distance as, let's say, we're gonna use cosine theta. Let's say this is theta. Yan. Diba, theta is the ratio of the horizontal distance, which is 3, divided by the hypotenuse, which is 5. And so, if I want to describe this in terms of X, then I can say that the moment arm is X multiplied by 3/5. Yan. So, here I have 76.5625 multiplied by X times 3/5. Yan. And then, for DB, segment DB, I have 76.5625 multiplied by 1.5 plus the moment right here. Still considering this perpendicular distance. So, this is now 1.5 plus X times 3/5. Yan. But then, I also have 75 kN. It's included in this segment. Again, this is our cut. We are considering all loads to the left. And then this is gonna cause a counterclockwise movement about the cut. So we're gonna use minus. So minus 75. And then our moment arm is X multiplied by 3/5. Yan. Now, by the way, ito yung nangyari. I will just remove this para hindi kayo malito. Diba, yung limits natin is 0 to 2.5 and 0 to 2.5. Now, that limit is along the slope of member AB. So, essentially, ito yung X natin. Ito yung X. And then we have, this is 3 and this is 5. Now, if you want the horizontal distance in terms of X, then that's why we're gonna use 3/5, which is cosine theta. Bale, yung horizontal distance pala is X cosine theta. But cosine theta is just equal to 3/5, the ratio of the adjacent side to the hypotenuse. So, x times 3 over 5. Again, x is measured at an angle. Naka-incline kasi yan. So, this is x. That's actually parallel to the member. Napangit yung pagka-draw. Palitan natin. Yan. This is x. Saka ito rin. So, I hope klaro. And then, for the last segment, I have segment BC. Let me just write this as segment CB. Now, I want to consider segment CB so that I will already not include AY saka 75 kN. So, our origin will be from C ending at B. So, from here, patungo dito. Now, if you will establish a moment equation from the right, then the convention will change. Yung counterclockwise movements magiging positive, and then clockwise movements will be negative. So, notice that CY will cause a counterclockwise movement about this cut. So, I'm gonna use positive. So, 48.4375 multiplied by X. Change ko na lang yung quality. Settings. Kaya pala, naka-fast pala. Medium. Yan. So, 48.4375X for this load, and then for the distributed load, we can define this as X. Again, X is always measured parallel to the member. So we have X, and then this now becomes, this will cause a clockwise rotation about the cut. So we're gonna use minus, kasi again, the convention will change, and then the resultant expressed in terms of X is 10x. And then its moment arm is x divided by 2. Yan. So, this is now our moment equation for the real system. Now, how about for the virtual system? Now, for the virtual system, although wala tayong load dito sa point D, we still have to divide it into two segments. Kasi whatever you are forming dito sa moment equation mo for the real system, it has to be consistent with the virtual system. So let me write D at this point. Again, all the loads are excluded. So for my MV, considering segment AD, I have 0.625 multiplied by X times 3 over 5. It's just the same dito, yung moment arm. But the load is already 0.625. So I have 0.625 multiplied by X times 3 over 5. The same moment arm. And then for the second one, I have 0.625, and then this is now 1.5 plus X times 3 over 5. Again, our moment arm is 1.5 plus the component along X along BD. That's why we have 1.5. And then next, I will just consider the right side. So from the right, patungo dyan. Again, what you will consider as your origins dito sa member, it has also to be consistent with the virtual system. Since this is from the right, then my equation for the virtual system must also be from the right. So this load causes a counterclockwise rotation about the cut right here. So we have to use plus, so 0.375 multiplied by X. And so finally, we are going to apply integration. Now we have three segments. We have AD, DB, and we also have BC, or let's just write CB. Yan. And so we have to sum up the integral from A to B of M multiplied by MV. And then we have here 1 over EI, since this is a constant term. Now for AD, we have to multiply M by MV. So this is M, and then this is MV. And so we're gonna multiply both, and then we have to set up the limits. We have integral from 0 to 2.5. 2.5. Yan. And so integrating this expression, we get 89.72. Or let's just store the values. Lagay ko na lang. Integral from 0 to 2.5. 76.5625 times x times 3 over 5 multiplied by 0.625 times x times 3 over 5. So press equals, we have 89.7216. So I will store this at A. So 89.72 stored into A. And then for the next one, we can set up the limits 0 to 2.5, and then M multiplied by MV. So I have this expression multiplied by MV. So 76.5625 x times minus 75 times yan. And then this is multiplied by MV, which is 0.625 multiplied by 1.5 plus x times 3 over 5. Now, meron pala tong dx. Lagay na lang natin. Yan. So, masyadong mahaba. Try natin kung kasya. So, integral from 0 to 2.5, and then I have 76.5625 multiplied by 1.5 plus x times 3 over 5 minus 75 times x times 3 over 5. This is to be multiplied by 0.625 times 1.5 plus x times 3 over 5. Yan. So, press equals, we have 408.325. So, is-store ko to sa B. So, 408.325 stored into B. So, shift store B. Yan. And then, for the last segment, I have CB. So, integral from 0 to 5. And then, we have this expression. Copy natin. This is to be multiplied by 0.375x. This is MV. So, lagay natin sa calculator. We have integral from 0 to 5, 48.4375 multiplied by x minus, this becomes 5x squared, and then times 0.375x. So this gives us 463.867. So I will store this into C. So shift store C, and then for yung tanong is the vertical displacement at joint B. Now we are given E saka I. So E is 200 GPa, and then I is 500 times 10 to the 6 mm to the 4th. Yan. So, diba, to calculate the deflection at this is the vertical displacement at joint B, then I have to add all of these values. Lahat ng yan. And then, diba, all of these are multiplied by 1 over EI. 1 over EI. Yan. So, I have A plus B plus C divided by EI. Masosolve ko na yung maximum deflection. But, take note that the force is expressed in Kn. And then, the distances are expressed in meters. So, the resulting unit here will be Kn m cubed. But, I have to make this consistent with EI. Now, to make this consistent, diba, we have to convert Kn into newtons, and then we also have to convert m cubed into mm cubed. So I can multiply this expression by 1000 to the 4th. And then for EI, we have 200 GPa. Convert that to MPa, we have 200 times 10 to the 3. This is Newton per mm squared. And then multiplied by 500 times 10 to the 6 mm to the 4th. Now, since we are multiplying here by 1000 to the 4th, essentially, our resulting unit will now be Newton mm cubed. And then mm squared will cancel. Also Newton. We have here mm squared. So, mm cubed divided by mm squared, that gives us a unit of mm. And so that will be our deflection. So this is the vertical displacement at B. So this is now A plus B plus C times 1000 to the 4th divided by 200 times 10 to the 3 times 500 times 10 to the 6. So we have this value, which is 9.619. So 9.6192 mm. Yan. Now, there's also an app to check this value. So, instead of deflection light, try to go to close natin. We have SWFAA 2D frame. Now, this is available for Android devices. So, let's make a new frame. CC2 frame. Yan. And then, let's try to model this. We have, at 0, 0, the origin, we have a node, and then we also have a node at 1.5. This is a height of 2, half of 4. So, at 1.5, we have 2. So, let's zoom in. 1.5 is to a height of 2. So, meron tayong node dito. And then, at 3 meters, at x equals 3 meters, we have a height of 4. So, we're gonna add another node. At 3, we have a height of 4. Yan. And then, at x equals 8, we have a height of 4. So, x equals 8. Andito, we have a height of 4. Yan. So, let's zoom out. And then, we're gonna add frame elements. So, let's connect the nodes. We have a frame element dito rin, saka dito. And then, we have a hinge support at A and a roller support at B. This is actually point C. And then, at this segment, we have a uniform load. So press this icon, go to distributed, and then click on the member. So press UDL for uniformly distributed load, and then we have 10. So save. Meron na tayong loads. Now, let me just remove the results. Yan. And then at this node, we have 75k and acting downward. So let's apply a nodal point load right here. And then by default, all loads are acting downward. So we have here 75kn. Yan. Now, we still have to modify the section properties. Kasi we are given 200 GPa for E, and then for I, we have 500 times 10 to the 6. So to make a section, click on this icon and then click on member sections. So press plus, and then for the material properties, we have 200 GPa, so this is fine, don't change this one. And then for the moment of inertia, we have 500 times 10 to the 6. So 500 E, let's just use this 500 times 10 to the 6. So we have this value. And then click on create. By the way, we have to change the name. Let's make this frame 1, so create, and then we're gonna modify these members. So click on the member and then apply frame 1 for a while. Click on the member, click on this icon, and then choose frame 1. Also for this one, frame 1, and then the last member, so frame 1. Now we're gonna show the axial force diagram. It will look like this. This is the shear force diagram. This is the bending moment diagram. And then we have here the slope and deflection. Now, clicking on deflection, we have the following deflection at point B. dy is minus 9.629, which is the same with our answer, 9.6192. Yan. So this is now the diagram of the deformation. So this is the elastic curve. So 9.629 is the movement of B along the y-axis. Yan. This is done. Problem 6. So we are now on problem 7. Copy na lang natin for a while. Problem 7. Okay. So for number 7, we have a prop beam fixed at the left having a span of 6 meters. It carries a uniform load of 40 kN per meter applied at the fixed support to 2 meters from the propped end, and a clockwise moment 100 kN meter applied at the propped end. Now we have to calculate the slope at 3 meters from the fixed end. So we first have to draw the problem. Kasi diba, wala kasing figure. So we have a prop beam fixed at the left. This has a span of 6 meters. So 6m. And then it carries a uniform load at the fixed support to 2 meters from the propped end. Now the propped end is right here. So from 2 meters daw from the fixed support, dyan magsta-start yung distributed load. And then it will extend up to the propped end. So this is 40 kN per m. And then we have a 100 kN meter load applied at the propped end, acting clockwise. So this is clockwise, and then 100 kN m. Yan. So I can copy this, and then diba, at first we have to remove the redundant support. So let me just remove the roller, and then we will now try to solve the deflection due to this loading. So again, the support was removed. Yan. So for cantilever beams, it's ideal to use anong tawag dito? Area moment. Kasi alam kasi natin na yung slope dito sa fixed support is actually 0. So, when drawing the tangent line at this point, it will be a horizontal line. So, it will be easy to calculate the deviation. So, this is point A, this is point B, and this is point C. Yan. Now, since andito naman tayo sa struct, automatic na lang natin i-solve yung reactions. Diba? For AY, we will just sum up forces vertical. And then, summing up forces vertical, since we only have this distributed load as the vertical load, then we have 40 multiplied by, 6 meters. And then this is 2 meters. So, the span of the distributed load is only 4 meters. So, 40 times 4, that will be our reaction. So, 40 times 4 gives us 160. Tama ba? Type ko na lang. Merong trust issues. So, 160, and then the moment is we have here the resultant 160, and then MA becomes MA is 160 times, this is 2, half of 4, 2 plus 2, we have 4, and then minus, this is plus again, so plus 100 kNm. It's acting clockwise, so MA is 160 times 4 plus 100. We have 740. Yan. Now, we're gonna write the moment diagram by parts. So first, by the way, we can actually include, we can lalagay natin yung supports ulit, and then, ano na lang natin, we will just equate. Lagay ko na lang yung BY para maiba naman. Now first, I will write the moment diagram by part caused by BY. So, we have here a straight line, and then this is 6 BY. BY multiplied by the moment arm, which is 6. And then since this load causes an upward rotation about this moment center, then I have a positive area. That's how you can check. So this is actually about A. And then we can project a line from the distributed load. So, by the way, parang mali yung figure. Applied at the fixed support to 2M from... okay. Sorry. Mali pala yung figure. This has to be from the fixed support, and then ito yung 2 meters. Kasi applied at the fixed support to 2 meters from the propped end. Ito yung 2 meters from the propped end. Sorry. So, change natin. Yan. So, mag-iba yung moment reaction natin. Remove ko na lang. But this is still 160. 40 kN per M. Yan. So, the moment at A is 40 times 6 multiplied by 3, which is 720. Yan. Pasensya. So, 720 kNm, and then, again, I'm gonna take moments about A. So, andito pala yung line natin para sa distributed load. And then, diba, yung value ng moment diagram by part, always aakyat yan sa moment center. Moment center is about A, and so for the distributed load, I have this figure. Magiging paganyan. Aakyat yung height sa moment center. Now sir, bakit to negative? Notice that if this is your moment center, try mong hawakan yan. Hawakan mo, tas apply mo yung load na distributed, it will cause the beam to rotate downward. If yung rotation is downward, automatic negative yung area. Tas pag upward naman, yung yung area is positive. And so this value is 160. By the way, meron pa palang 40 times 6 times 3, and then meron pa palang plus 100. Plus 100, so this is 820. Yan. So, we have here 160 multiplied by the moment arm, which is 2. Now, again, ito na yung 4, and then this remaining distance is 2 meters. So, 160 times 2, this gives us 320. And then automatically, the sign of this value is negative. Kasi diba, this is below the zero line. So let's just write minus. Yan. Now, we are already done with BY and also this load, 160 kN. But we are not yet done with this clockwise movement. So we have to draw another movement diagram by part. Now, just extend this load. Again, pwede mo yang i-overlap. But ideally, just draw another zero line so that it won't be confusing. So we have here 0, and then this is clockwise. Now, this is our moment center. A clockwise movement will cause the beam to rotate downward. So meaning, we have a negative area. And then diba, since this is a moment load, it will just be a constant line. So we have a straight line from point C. Let's just use green. We have a straight line from point C. From point C to A. Yan. So this is minus 100. Again, minus kasi yung clockwise movement will cause a downward rotation about the moment center. I hope klaro. So now, we have BY, this load, and this load. So now, I can equate the deviation from C with respect to the tangent at A. It must be equal to 0. Kasi diba, this is a propped end. Walang deflection na mangyayari dyan. So, solving this, then I can take moments, diba, we always take moments about the first letter. So, we need to take moments about C, and so we first need to establish the centroids of the figure. So, for 6BY, this is just a triangle with a degree of 1. This has a degree of 2. Again, this is 2 because this is 0 degrees plus 2 for the moment. We have to the second degree. Now, this centroid is what is the base of this triangle? Diba, it's the whole span of the beam, which is 6 meters. So we have 6 divided by 3, 1/3 of 6. And then for this spandrel, we have a base of only 4 meters because this is for the distributed load. And so our centroid is somewhere here, and then this value is patungo sa height, it's always b over n plus 2. This is the formula of the centroid. So the base is 4, and then the degree is 2. So 4 over 2 plus 2. This becomes 1. And then for this load, this is just a rectangular area, so the centroid will be at the center. And so this distance will be half of 6, which is 3 meters. And so I'm gonna solve TCA. This requires me to write the area moment equation. So first, I'm gonna solve the area of this triangle. So the area of that is 1/2 times a base of 6 meters times a height of 6 by. So 6 by. And then we have here, this is a negative area, so minus the area is 1/3. Now sir, bakit 1/3? The degree is 2. And then for the area of a spandrel, we have BH over n plus 1 as the general formula. So this is now 1/3 kasi 2 plus 1 is 3. And then the base is 4 meters. The height is 320. And then this is still a negative area, so that's also minus 100 multiplied by the base, which is 6. And then multiplied by the moment arm, which is 3. Yan. Now, hindi pa natin nalagay yung moment arm dito sa triangular load saka distributed load. Move na lang natin. For the triangular load, again, we are taking moments about C. So, this is the moment arm going to C. Yan. So, diba, this is 2/3 of 6. So, 2/3 ng 6. And then for this spandrel, the moment arm going to C is, I hope you would agree na it's 6 minus 1. Diba, kasi this is 1. So, going to C, we have 6 minus 1. Yan. So, we can now solve the deviation of C with respect to A. But diba, alam natin na this must be 0. Kasi walang deflection dito sa C because of the prop support. So now we can solve BY. So I have 1/2 multiplied by 6 times 6x times 2/3 of 6, and then minus 1/3 times 4 times 320 times 5 minus 100 times 6 times 3. I have to set this to 0. So solving BY, I have 54.629. Or let's just say 54.63. So BY equals 54.63 pala. This is KN. Yan. But di pa tayo tapos. Yung question kasi is calculate the slope at 3 meters from the fixed end. So copy natin to, and then lalagay na natin yung reactions. For a while, merong nag-message. Include ko sa live. Wait lang. Pagkatapos nito. So, lalagay natin yung reaction. Diba? We have 54.63. 54.63 kN. Now, we first have to solve the reaction at A and the moment reaction and the vertical reaction. Now, what is AY? AY is just gonna be, we have summation of forces vertical, AY plus, AY minus 40 times 6 plus 54.63 equals 0. So, AY is 40 times 6 minus 54.63. So we have 185.37. Yung base ng uniform load is 4 meters pala. So this is only 4. So we have 105.37. So AY equals 105.37 kN. And then solving MA, we have 40 times 4 times 2 minus 54.63 times 6 plus 100. Yan. So we have 92.22 kNm. Yan. So now, since we only want the slope, diba, the slope at 3 meters from the fixed end, then we only need the area. Diba, yung slope is defined by the area of the moment diagram by parts. So let me just write a line. This is 3 meters. And then let's form the moment diagram by part only up to this point to simplify our solution. So here we have, let's draw another line, and then I have 0 for the 105.37 load. Let me just treat this point as the moment center. Moment center. And so the height will climb this point. So I have 105.37, that's to be multiplied by 3 meters. So 105.37 times 3, this gives us a height of 316.11. Yan. And then for the moment load, we have 92.22 acting counterclockwise, so that's going to be a negative area because this will cause a downward rotation if this is your moment center. So minus 92.22. But we still have a distributed load. So let me just write another 0 line, and then we're going to include the moment caused by the distributed load about the moment center. So this is gonna be 40 minus 40 times, this is only 3, so times 3 times 3 over 2. So this gives us 180. Yan. So now I can solve the area of these shapes, and then that will define my slope. So this is my tangent line TA, and then parang ganito kasi yung ano niyan, yung elastic curve. So this is my second point. Let's draw a tangent line. Pero di naman yan magmamatter. Let's just say this is point D, TD. Yan. So the slope at D with respect to the tangent at A, this is 1/2 times a base of 3 meters times a height of 316.11, and then minus 92.22 multiplied by 3, and then since this is a spandrel of a degree of 2, so we're gonna use 1/3 times the base, which is 3 meters multiplied by a height of 180. Again, this is negative because this is essentially a negative area. So the slope at D would be 0.5 times 3 times 316.11 minus 92.22 times 3 minus 1/3 times 3 times 180. So we have 17.51. 17.51 kNm squared divided by EI. Yan. 3I. The beam is indeterminate. So this is the answer. 17.51. Problem 8. What is problem? EOS 003. Yan. Yung tanong is, calculate the deflection at B. Yan. Now, for these problems, mas maganda yung virtual work i-apply. So, we want the deflection at B. Yan. So, I have to draw a virtual system which will exclude the loads. Yan. So, this is 6 meters and 3 meters. I have here A, point B, and C. Now, I want to calculate the deflection at B. And so, I need to add a virtual load, a unit load here at point B. This is 1. So this is my virtual system. Virtual system. Now for this real system, I have a resultant, a reactive force acting upward equivalent to this load, 100 kN. Kasi diba, this is only a moment load. So this is only the vertical load. And then we have a moment reaction of, sabihin natin MA, this is 300, the clockwise load, plus 100 multiplied by 6. So 100 times 6. This gives us 900. Yan. Indeterminate beam. So this is non-prismatic. Magkaiba yung sections. This is 2EI, this is only EI. So now, applying the virtual work method, diba, my reaction here will be, you can just actually use inspection. Huwag ka nang mag-solve ng reactions dito na you have to write down. So this has to be 1, and then our moment reaction has to be 1 multiplied by 6. So that's gonna be 6. So this is now my virtual system. This is my real system. So I'm gonna write down the limits, and then we have member AB and member BC. Let's just use member CB so that our solution will be more efficient. You will see later why. This is CB. So our limits for AB is from 0 to the length of the span, so that's 6. And then for CB, I have 0 to 3. And then for M, it's easy because we only have a moment reaction and a vertical load. So this is gonna be for segment AB minus 900 plus 100x. And then for MV naman, I only have minus 6 plus 1x. again, we are making this cut. We are considering the section to the left. And then our origin is from this point up to the cut. So this is our x. And then for CB, notice that we only have a 300 kNm load. So this is from the right, so the convention will change. So this is actually minus 300. But for my virtual system, it's gonna be easy because for segment CB, if I will just consider the load to the right, this is my cut and then this is my origin. Notice that there is no loading at these points or at segment BC. So this means that this is essentially 0. So this is now excluded in my solution. I will only include this one. So I have the integral from 0 to 6 and then minus 900 plus 100x multiplied by mv, which is negative 6 plus x, and then we have dx. Now we're gonna divide this, we're gonna multiply this by 1 over 2ei because for segment AB, this is our section. We have 2ei. So now we're gonna integrate 1/2 to account this constant or factor, and then we have 0 to 6 and then minus 900 plus 100x multiplied by minus 6 plus x. So this gives us 6,300. So 6,300 kNm cubed divided by EI. However, we are given the section properties. We have I equal to 500 times 10 to the 6 and then E is 70 GPa. So then I have to convert this into Newton mm cubed, so 1000 to the 4th, and then my E is 70 GPa. Convert that to MPa, we have 70 times 10 to the 3, and then I is 500 times 10 to the 6. Yan. So now we have 6,300 times 1000 to the 4th over 70 E3 times 500 E6. So this gives us 180 mm. This is the deflection at point B. Yan. Reactions. Switch account. Using double integration, MA is unknown. So 2 redundant forces. So, ito na lang yung last natin. Problem number 9. Ay, ba't wala natin? TOS-005. Nako, di natin nasali. Pero yung number 9 connected sa TOS-002, problem 2. And then we want to calculate the magnitude of 6AB over L. So, madali lang to. Wait lang. Ito na lang yung last natin. Yung merong internal hinge. Yan kasi yung mahirap. TOS-002. Diba, for yung tanong dito sa problem 9 is connected sa item number 2. So, ito yung item number 2. We have to calculate 6AB over L. Now, this is about B. Now, we already have this point. Let's consider this as the first span, AB, and then this is BC. Now, diba, in 3-moment equation, you have to divide the spans. Let's say this is the first span. This is A, this is B. And then, for the second span, this is now A, the left side, and this is B. And so 6AB over L is just gonna be 6 times, diba, we already took moments about B, which is 9283.95. This one, the deviation of C with respect to A. So we have here, treat na lang natin as the whole beam. This is A, this is B. So we have 6 times 9283.95. Divide natin by L, which is 12. So this gives us 12 EI pala. We have 4641.975 EI. And then this is, ano yung unit dito? Meter. This is kNm cubed divided by meter, magiging kNm squared. Pero ito na lang yung isulat mo. May tumatawag. Wait lang. Sige. Kinasangан? Okay. Masa ko dead on? Panglakaw? Okay. End ko na lang muna yung stream, mga lodi. Wala. Gas stream ko rin. Sa next session naman, we will solve problem 9 problem 4 saka problem 10. Moving load sa truss saka deflection when the beam has an internal hinge. Yan.